welcome to another AQA A-level chemistry video. Did I say AQA as chemistry in the last one? Hopefully I didn't, but welcome to another AQA A-level chemistry video. This is our A-level, AQA A-level year 2 chemistry, and it's organic chemistry as well. So, this video is going to be on biodegradability. You'll be glad to know that it should be, if I don't waffle, it should be a short video. And I do this video because it is important because you'll get 6-month questions in your exam where you would need to basically just comment on. It's something that you could use to comment when it asks you to evaluate. Basically in your exam you get a question where they will ask you to evaluate the use of one type of polymer over the other, and there'll be things like how strong they are, and has to do with the intermolecular forces, the physical properties of it. But it's also about how easy it is to dispose of that compound. And when we're talking about disposability, we're talking about mostly how easy they biodegrade and whether or not they do biodegrade. And so yeah, I'm gonna go straight into the video. I'm gonna talk about this topic. So I mean, this is just one of the things that you can. It's one of the things that you have to mention. I don't believe there's anything else you really have to mention, but they would ask you about how easy it is to dispose of the compound in your evaluation. They'll give you like they should give you a list of things to evaluate. It'll be like a 6-marker. They'll give you like a list of things to evaluate, but even if it doesn't give you the list of things that they want you to talk about, you should know that it should be talking about if they're talking about evaluate which one is more useful or more suitable for industry, they'll probably give you a list about the energy needed to make the compound, and how much energy gets released from breaking the compound down, how much energy is used to break the compound down, as well as how strong it is, things like that. So yeah, I'm not gonna go through that in too much detail because I mean that should be quite easy to see. But I will be talking just mostly about just biodegradability. The other content is quite GCSE, so hopefully this will be quite straightforward. So, disposal and biodegradability of polymers. So polymers can be disposable. Sorry, polymers can be disposed of in different ways, depending on their properties. Polyalkenes are non-biodegradable, but polyesters and polyamides are biodegradable. So one type of disposal is incineration. Incineration is just burning the polymers to produce energy for electricity, and this reduces landfill space, but toxic gases are released and greenhouse gases are produced. So this is actually a type of way to produce energy. They do this with mostly plants and trees, but I mean I forgot the type of power source that is. I forgot the name of it, but you can also do it with waste as well. So you can incinerate it, and as you burn it, energy is released. When energy is released, so obviously combustion is an exothermic process, so energy is released. You can actually use that energy to either turn a turbine or of some sort. You can use heat water that will produce steam. The steam will then turn a turbine that pushes then powers a generator, so on, so on, so on. But you don't need to know too much about the complexities of it. But just knowing that incineration is a type of way to dispose of compounds, and it has uses producing energy, of electricity. But there are drawbacks to it because it does release toxic gases and also releases greenhouse gases, or produces and releases greenhouse gases. Another way is recycling. So recycling saves raw materials, which is important when considering that many of these polymers are produced from crude oil. So, and most crude oils will get left as waste that we can't really recycle and reuse again. So if we are able to recycle them, that would be a very good use. Less crude oil is going to be used, less greenhouse gas is going to be released. But polymers need to be separated and organized, which is quite an expensive process. So there, put this here. Always forget to do this after literally every single time. Another type of disposal is landfills. Landfill is the most common method of disposal of waste in the UK. Many landfills are now reaching the full capacity, so we're trying to avoid this, which we are trying to mostly avoid this, but this is unfortunately one way that we can destroy things, and usually just us digging up a random hole in the middle of nowhere and then filling it with waste and then covering it over again. And it's not the best way to dispose of things, you know. I think it's pretty self-explanatory why if you want to get rid of something or you want to completely get rid of something, you're not going to just bury it in your garden and then cover it up. You either incinerate it or try to recycle it. It's worse for polyalkenes because they biodegrade very slowly. More biodegradable polymers such as polyesters and polyamides are better. So biodegradability of polyalkenes. So polyalkenes are made up of strong carbon-carbon and carbon-hydrogen bonds, and so biodegrades slowly in landfill sites. In fact, they biodegrade so slowly. So, for example, for polyamides or polyesters, because they as I said in previous years, they got the hydrogen bonding. If you include the base of some sort or an acid, you can actually undergo hydrolysis, which makes it very easy to biodegrade and break the bonds and actually break down the compound. Makes it very easy to biodegrade. But because polyalkenes only have strong carbon-carbon covalent bonds, um, strong carbon-carbon covalent bonds and strong carbon-hydrogen bonds, these are very strong bonds, and they are non-polar, and therefore you can't. There's no electronegative atom like an oxygen or a nitrogen to break it to use to break that. Sorry, there's no electronegative oxygen or nitrogen atom with polyamides where there'll be hydrogen bonding, which makes it very polar. To where you can add a base or an acid to undergo hydrolysis. There's none of that. It's just very non-polar, strong carbon-carbon and carbon-hydrogen covalent bonds. So they're considered to be, they're so slow in biodegrading, they're actually considered that they don't biodegrade. It takes probably like 1,000 years or something like that to actually biodegrade, some of these polyalkenes. But polyesters and polyamides are pretty easy to do. A couple like you can do that like in a month or two, and they biodegrade pretty easily. But polyalkenes thousands and thousands of years to actually biodegrade. So we just consider it to be non-biodegradable. But biodegradability of polyesters and polyamides. So polyesters and polyamides can be broken down by hydrolysis, as I said before, and so are biodegradable. Their activity is due to weak polar bonds in the polymer chain. So nucleophiles such as water can break down the polyester or polyamide chains. The hydrolysis reaction can be achieved in either base, or which is a hydroxyl group, or an acid, which is a H plus. The acidic hydrolysis produces the original monomers, and the basic hydrolysis produces the salt of the dicarboxylic acid monomers. Now, I want to cover up on this point here that some people kind of confused on. When I meant that, when I meant here, when I was talking about the due to weak polar bonds. Well, overall, hydrogen bonding is stronger than weak van der Waals molecular forces. It is. Like in terms of like holding it, it's stronger than it's weak than weak van der Waals molecular forces here. But when we're talking about if you add a base to it, like if you just hold, if you're talking about like if I was to like a physically pull. I think like in certain okay, in Africa right now, uh, the plastic, not single-use plastics are completely banned, and you have these new uh polyamide bags now, or like uh condensation polymer bags. So in Africa right now, in most countries in Africa right now, they have these uh very biodegradable uh condensation polymer bags that if you actually try to physically pull them apart, they're actually very difficult to pull apart because the bonds are very strong. It's a very, very strong bond compared to polyalkene bags or non-biodegradable polyalkene bags, which are actually, you can pull them apart. If you get like a Tesco bag right now, actually you can pull them apart. Or the old Tesco bags, I should say. But if I was to leave those bags in Africa, which the polyamide types of bags, if I was to leave them in a landfill with water and a base of sorts, and let it biodegrade, it would biodegrade very easily. Those bonds would be broken really easy. And so in the presence of a base or acid for hydrolysis, they break down very easily. But with that type of process doesn't really work with polyalkenes. It doesn't do that. So I just wanted to clear that up because some people think that these polar bonds, so these condensation polymers weak. Condensation polymers are not weak, but when you're biodegrading them with the bases, they become weak. Yes, but it doesn't do this process with polyalkenes. Hopefully, I made that clear. Hopefully, I said it enough times. And also want to cover out one last thing, right? In biology, hydrolysis can be done with water. But then once I talked about it with my chemistry teacher, it doesn't make any sense. Like breaking something down or breaking these compounds down with just water. If you put water on top of one of these bags, it doesn't break it down. Nothing will really happen to it. It's a very weak compound solvent to, I say, sort of solution to break down polyamides. But in biology, I guess water is enough to do it. But when you're talking about in chemical compounds, you use an acid or a base for hydrolysis. But yeah, so if you're looking, if you think about hydrolysis, you think about water. Think generally about biology. But for chemistry, you need an acid or a base. And for talking about breaking down, and when I go into proteins, the next video will be about well, in 2 videos time will be about proteins. That video will explain how to break down how to hydrolyze polypeptides, and polypeptides, you need to leave them in acid for a 6 molar of HCl, yeah, 6 moles per dm cubed HCl for 24 hours. You see, but that won't work with water. That's hydrolysis for proteins. 6 molar HCl solution with the protein in it for 24 hours, and that's actually enough for hydrolysis. But anyway, now I've kind of explained that point, little brief points there. But you can clearly see here that they're highly polar breakable bonds here when you're talking about these condensation polymers. Highly polar breakable bonds. But that's it. Hopefully this video was constructive and you found it useful, and that's it. Bye.